everyone, I hope you guys are doing well. Today I am going to record a series based on the differential equations, okay? And I start with the basic definition of the differential equation. So before going to the basic definition of the differential equation, I will try to introduce the dependent and the independent variable. For example, we have the given function, single valued function y equals to f of x, right? Where f is the function of x. So here two variables are there, y and x. So if I talk about y, so y totally depend on x. It will give you the value in respect to x. So y is dependent variable, okay? Dependent variable. And what about the x? X is independent to take any real number, okay? So it is independent variable, okay? Independent variable. So now simple, if I talk about the definition of the differential equation, so simply I will say an equation which involves dependent variables, independent variables, and derivatives of dependent variable with respect to one or more independent variable, one or more independent variable is called differential equation. Simply is called differential equation, right? So we have a very simple definition of a differential equation. So if someone asks the definition of the differential equation, so you can write this, okay? And what about the examples? So we have number of examples here. Now example number 1, if I talk about, then I can write dy upon dx is equals to 1 plus x square upon 1 plus y square. It is one of the example, okay? So in this example, obviously I have one independent variable, okay, and one dependent variable, okay, and dy by dx is the derivative of the dependent variable with respect to independent variable, okay? Derivative of dependent variable with respect to independent variable. So it is a very simple example for this. And second example we can take here, d square y upon dx square is equals to minus 2 times dy upon dx and minus 8y is equals to 0, okay? Oh, sorry, it may be, I think it should not be here, minus 2 dy upon dx minus 8y is equals to 0. So it is the first class example, another example of the differential equation. Obviously we have here second order derivative involves, so it is the second order derivative. I am writing here second ordered derivative, okay, we say it. And what about this? It is our first ordered derivative, right? So in this differential equation, second order derivatives, first order derivatives, dependent variables and independent variables are involved. So it is first class differential equation, okay? And here we talk about types of the differential equation. So types of the differential equations, right? There are two types of the differential equation. First, ordinary differential equation. Right? Now, what do we mean by the ordinary differential equation? We also said it as ODE, ordinary differential equation, right? An equation, simple definition, an equation which involves dependent variables, independent variables, and derivatives of dependent variables with respect to one independent variable. With respect to one independent variable is called ordinary differential equation. Very simple. So there should be one independent variable in case of ordinary differential equation, right? And you can quote examples, the above two examples. Basically, in the example number first, here we have the derivative of the dependent variable with respect to one independent variable. So it is the first class example of the ordinary differential equation, ODE. And the second example is also we can say it has derivatives of the dependent variable with respect to one independent variable. So you can put it into the category of the ordinary differential equation also. Okay, and there are number of examples for such type of ordinary differential equation. I'm writing here fresh examples also, like 1 plus dy upon dx whole square to the whole power 3 is equals to d square y upon dx square. Okay, and whole square you can say. So it is the another example of the ordinary differential equation, right? And I am also writing here one more example for the ordinary differential equation. So cos x, like cos x, okay, d square y upon dx square, and plus sin x dy over dx whole square, you can say like this, okay, and then plus 8y is equals to 10x. Okay, so it is the first class example of the ordinary differential equation. Now simply you can say we have the two examples here for the ordinary differential equation, and there are number of infinite such differential equations are there. So now I'm going to introduce the second type of the differential equation, that is the partial differential equation. Partial differential equation. So what do we mean by the partial differential equation? We also say it like PDE, okay, partial differential, we represent it as PDE, partial differential equation. So an equation which involves independent variables, dependent variables, and derivatives of dependent variable with respect to more than one independent variable. Is called PDE, partial differential equation. Okay, and we have the simple examples here, like if you talk about del square z upon del x square and plus del square z upon del y square is equals to 0. One of the examples. Here we have one dependent variable z, okay, and two independent variable, x and y. Okay, two independent. There are more than one independent variable. There are involves derivative with respect to more than one independent variable. So you can call them partial differential equation. Okay. Now we talk about here order and degree of the differential equation. Okay, order and degree of the order and degree of the differential equation. Okay, so what do you mean by the order? The order of a differential equation is the order of the highest differential coefficient present in the equation. Okay, or we can say the order of the differential equation is the order of the highest order derivative involves. Highest order derivative involves in the given differential equation, in the present differential equation, is called, or you can say you can stop here. Okay, the order of the differential equation is order of the highest order derivative involves in the given differential equations. Okay, and the for example you can say if I told this, what about this? So here two derivatives are involved with respect to x and with respect to y. So there are second derivative involved. Okay, so the order of the differential equation is of this differential equation is 2, and we also call the previous one example like the order in this differential equation obviously 1. It is first ordered differential equation, and you will say first ordered ordinary differential equation. Okay, first order ordinary differential equation. What about this? You can call them as second ordered ordinary differential equation, ODE, right? Second order ordinary differential equation you can say that. What about these? Okay, it is the second ordered ordinary differential equation, right? It is what about that? It is also second ordered ordinary differential equation, because the highest derivative involved in this differential equation is of second order. Okay, so you can simply find the order of the differential equation. Now what about the degree of the differential equation? Okay, so I'm writing here degree. Okay, degree of the differential equation. So how will you say the order of all the above? The degree of a differential equation is the degree of the highest derivative after removing the radical sign and fractions. Okay, so you can say in the simple words, the degree of the differential equation, the degree of the differential equation is integral power of highest ordered derivative involves okay, involves after removing the the radical sign and fraction. Okay, for example, you can say like square root of 1 plus dy upon dx square, okay, is equals to d square y upon dx square to the whole power 3 by 2. So basically here the highest derivative involves is d square y upon dx square. So what about the power of this is 3 by 2, but it is in the fraction, and in the left hand side we have the radical power. So what should we do? We have to remove the fraction and the radical for both the sides. So we take the square of both the side. So we can say 1 plus dy upon dx whole square is equals to d square y upon dx square to the whole power 3. Okay, so it is now free from radical and the fraction powers. So what about the degree? Now here we see the highest order derivative involved in this differential equation. So obviously d square y upon dx square is the highest order derivatives involved in the given differential equation. So what about the power of this? It is 3. So degree of this differential equation is 3. So you can simply find the degree and the order of the given differential equation. You can also say about the order and characterization of this differential equation. So you will say it is the second ordered. Okay, you can write here second ordered, third degree. What about this? Is it ordinary? Yes, it is ordinary differential equations. Okay, so you can characterize the given differential equation as. So guys, we will meet you in the next video. So keep watching and like, subscribe and comments. Okay, thank you very much.